Okay, so in this video, this is number 10 from your review, okay, and number 10 is asking us to take a look at the different ways to represent or find the inverse of a function. So these are all lines, as we studied in class, okay, and we did discuss 3 different approaches, although we did not explicitly call them approaches. We just looked at the way to find an inverse, okay. So the way we could do that is actually using a table of values, creating the table of values to find a couple points, and then reversing the x and y values. That's one method. That's what we'll do with question A. Question B, we can also reflect the line, so we can graph the line and then reflect it over top of that y equals x line that you're seeing, the orange line. I think what we'll do that for question C, and then for question B, I'll actually do the algebraic approach of finding the inverse. Okay, so for question A, we can find and create a table of values, right? So you can say x and y, where the output of y is going to be 2x minus 5, okay? And what we're going to do is create the outputs. So if I input -2, -1, 0, 1, and 2, that's lots of points, okay, for finding this. So if I substitute -2, I'll do the first one. 2 times -2 minus 5. That sounds like -9, right? So that point there would be -2, -9. Okay, and if I do that all the way down, so 2 times -1 is -2 minus 5. That's going to be -7, so that's going to be a point. -5, -3, and -1 should be those points. So what I'm going to do, I'm going to just go over to A. I'm going to plot those points. What I'll do is I'll plot the original graph in black, and then I'll plot the inverse in red, and we should see that the two are always a reflection in that orange line. Okay, the reflection being one of the methods that we could probably do if I graphed it, right? So I'm just going to plot those points for A. -2, -9 is going to be down here. Okay, and then -1, -7 is going to be here. And then 0, -5. Okay. And then we can kind of see the slope there, right? I don't need to plot the rest of the points, but we can definitely see that 1, -3 is going to be the next point, and that 2, what happened? 2, -1 is the next point. Okay, and I think we get the point for the idea. So I can connect those. Okay, and we're going to see that would be the graph of f of x, if you will, for this particular question, f of x. And what we're going to do now is for the inverse, we're just going to reverse the x and y values. So we're going to see -9, -2 is going to be the inverse. This would be f inverse of x, sorry. F inverse of x. Okay, and we're going to have x and y coordinal points. And then -7, -1, -5, 0. Okay, it should be all in quarter in brackets. And then -3, 1, and -1, 2. Okay, so I'm just going to plot those points too, and then you'll see that the red line, the inverse, should be a reflection of the black one in that orange y equals x line, right? So -9, 2. Sorry, -9, -2. 9, -2 should be here. Okay. And then -7, -1 would be here. And -5, 0 would be there. So on. Okay. Okay, and we should see that the red one is the inverse of the black one. Okay, so that's one method, creating a table of values, okay? As you can see, that's, I don't know, a little bit tedious. having to create the points. If you were ever given the table, like the table, not so bad, but to actually create the table values and then reverse them takes a little bit of time. Okay. For question B, I think is one that is not as nice. So what I'm going to do is use the algebraic approach for question B in order to graph it. What we can do is graph the original function though on B. So another way to write question B would be 1 over 7x plus 3 over 7. Okay, so that's not a great line to be graphing in the first place because I don't really know what 3 over 7 is. Okay, it's maybe just under 0.5. But in order to graph that accurately, we're going to have a bit of a problem, right? So what I'm going to do is just find the inverse using the algebraic approach for question B. Okay, so question B. There's 4 steps for finding the inverse. Okay, the first one is get rid of the function notation, right? So we're going to replace f of x with y, and we're going to get x plus 3 over 7. Step 2 said reverse the x and y variables. So we're going to get x is equal to y plus 3 over 7. And then step 3 was solve or resolve for y or re-isolate for y, right? So I'm going to multiply both sides by 7. So I get 7x is going to equal to y plus 3. And then I'm going to subtract 3 from both sides, and I'm going to get 7x minus 3 is going to equal y. The fourth step is to replace the y with f inverse of x now. Because what we want to be able to do is distinguish between what the original function was, okay? We want to know what this original function is versus what this one is, right? And we can see at the beginning, it's a little difficult to do that at the moment, okay, between step 1 and 3. So what we're going to do is just call this f inverse of x is going to be is equal to 7x minus 3. Okay, what I'm going to do is just going to go graph. I could graph that. I don't know if I necessarily need to, particularly because it's not, the original function wasn't very nice to graph. So we're not going to be able to actually communicate the point there. But you can trust the fact that the original would have been a reflection in that y equals x line, that orange one. Okay, I don't need to graph that one. However, for question C, what we're going to do, I'm going to try my best to use this notion or this idea of the reflection in that y equals x line to produce the graph of the inverse. Okay, so what we're going to do, we're going to take the original function, we can maybe rewrite it so that it's maybe a little bit easier to look at. Okay, so that's saying we have a y-intercept of positive 4 and a slope of negative 1/2. Okay, so down 1, right 2. So we're going to go find, I'm going to plot this. We have a y-intercept of 4, 1, 2, 3, 4. I'm going to go down 1, right 2 takes me to there. Down 1, right 2, down 1, right 2, down 1, right 2. That's probably lots. Okay, so what I'm going to do is I'm just going to connect those points if I can, best I can. Good thing I got that feature. Okay, so that's the graph of f of x. Okay, now here comes our problem. This one's a little trickier to do with the graphically, but just remember that these are just reflections, right? And I suppose if you have a series of points that we've kind of produced using just y equals mx plus b method, like just graphing a line, you could take those values. If you're stuck on actually looking at how to reflect that, you could just take that value there, let's say, and switch the xy values, and you get an idea of, you could confirm for yourself where that actual point goes after you've reflected it, right? So right now that's the point 2, 3. And so I could graph the new point of the inverse would be on 3, 2. right? So 1, 2, 3, 1, 2. Okay, so that's a direct reflection. As you can see, the red point would be a reflection of that black point from there, okay? And we can just do that all those times, or what we would need is, if you recall, we only need 2 points to create the line. So what we could do is we could take that easy one there, right? And say, okay, that's the x-intercept, which occurs at 1, 2, 3, 4, 5, 6, 7, 8, 0. That is going to go up to 0, 8, which would be a direct reflection perpendicular to that orange line, right? So right up to here, if I'm not mistaken. If I count that, that should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so interestingly enough, if we're looking at that graph, all these points are going to be reflections, perpendicular reflections, okay, in that y equals x line. Okay, and so that's what it means to reverse the x and y values of in the table of values for these graphs, because now I can just connect these two. Oops, I did the wrong thing. I can just connect these 2 points, and I can see that that red line is a reflection of the black line in the y equals x orange line, okay, which is the definition of the inverse. So that takes all 3 approaches that we've studied into consideration. Actually physically reflecting the points over y equals x when we've produced the graph, reversing the xy values of a table of values, and the actual algebraic representation of finding the inverse as well. Okay, so, and which you can tell from, again, we're reversing in step 2 basically all values of x and all values of y when I reverse the actual variables, okay, and then resolve. So that's finding the inverse, kind of compiled into one nice question there. All 3 methods, conceptually, it's all around that idea of y equals x though.